So let me just show you the tutorial sheet where we last time. We had completed question number 3. Question number 4 was already done in the lecture. Actually, this is the tutorial on divide and conquer and dynamic programming. Okay. So we have to finish 5, 6, 7, and 8. Okay, that's what we will do. Before that, I just want to tell you that tutorial 7, which is there, you can open that also. If you remember graph algorithms, I have made a modification. There were only 3 questions earlier. I have included 2 more questions, one for Kruskal's algorithm and one for Prim's algorithm. Okay, and I have already added example graphs on which you have to try these in MS Teams. So you'll find a PDF file in which there are 3 undirected graphs, there are 3 acyclic directed graphs, and there are 3 weighted undirected graphs. Okay, on which you have to try this. Okay, so I will not repeat these again. Is that okay? So just go through those look at those graphs and run these on those examples. Is that all right? Okay. Yeah. So question number 5. So 5 says the following. An m by n array is a non-gay array. So non-gay array if there is a small correction here actually. So yeah, this is correct. So yeah, forget m and n. Let's just consider n by n. Okay, just n by n. So there are 2 indices, right? Because one for rows and one for columns. So aij plus akl is at most ail plus akj. That is the definition. We'll see soon what the meaning is. Okay. So if this condition is satisfied for all ij kl, then we say that this is a non-gay array. And we are supposed to find out a certain thing about non-gay arrays. So what should we do? So first thing is to simply show that, okay, so this is a definition. For each I in one to n. What does that mean? For every row, every ith row, okay, f of I is the index of the column. Okay, index of the column means it is whichever column it is, first row, first column, then f of I is equal to 1. If it is the fifth column, then f of I is equal to 5. Okay, that way. So the index of the column containing the leftmost minimum, leftmost smallest element of A in row I. Okay. So f of I is the index of the column containing the leftmost minimum element in the ith row. Okay. Show that this is true. Okay. F of n less than equal to f of 2 up to f of n. Okay. So let's do that. So we are now on tutorial 5. Question 5. So what does that mean? So A, so let's not even look at n by n, let's just consider n by n, okay? Square array is a non-gay array if, what does that mean? See, for all I, j, k, l, okay, and I and j are supposed to be row column, k and l are supposed to be row column. So ith row and kth row, jth column and lth column. Okay, this is the ordering that we will assume. We have a ij plus a kl less than or equal to a I L plus A K J. What does it mean? Okay, it's very easy to see. Take the array A. Okay, so this is a rectangular array. It's a square array in fact, n by n. Okay, so there is an ith column. Sorry, ith row. There is a kth row. Okay, and k is greater than I. Right, so k is further down. There is a jth column and there is an lth column, right? So aij is here, akl is here, okay? ail is misspelled. Ail is the cross, is here, and akj is this element, right? And what does this say? Monge means, the diagonal sum is less than or equal to the opposite diagonal sum. So this diagonal sum is less than or equal to the pink diagonal sum. Is that alright? This is the meaning of the Monge array, and this is true for every pair I, K, J, L. Is that clear, everyone? Alright. So further, what are we really looking at? So let A be an n by n Monge array. Okay. For every I from 1 to n. What does that mean? For every ith row. Okay. F of I is defined to be the leftmost j. Okay. So leftmost j. Okay, j corresponds to columns. Leftmost column such that aij is the minimum among all the elements in the ith row of A. Okay, so minimum among A, I, T for all T when we do T. That clear? T varies from 1 to 8 numbers. Okay, the smallest element in the ith row, it could appear multiple times. You look at the leftmost position in which it appears. That j is defined to be f of I. Is that okay? So we have a of, by definition, I comma f of I is equal to minimum among the values a of I comma t, where t varies from 1 to 8. Right? That is a definition. So now the question A, says that we should have f of 1. One second, just give me 1 second. Yeah. So now the first one says that we should have f of 1 less than or equal to f of 2 less than or equal to. Okay. So we can prove any f of I less than or equal to f of I plus 1, and that is enough. The proof is more or less the same. Okay. So without loss of generality, we prove, let us simply prove f of 1 less than or equal to f of 2. Okay. Suppose this is not true. Suppose okay, which means f of I is a greater element than f of j, f of 1 and f of 2. Okay, so you simply compare the elements a1, f1, a2, f2, and so on. Okay, then what we get is a1, f2. Is that okay? Just check. This is the definition of boundary array because f2 is less than f1. Okay, f2 is the smaller element, right? However, just look at the definition of AI fi. This is the minimum value. So we already have a1 f1 less than or equal to a1 f2. Okay, just by definition of f. But then this inequality is getting reversed here. You see, you have the left hand side term greater than or equal to the right hand side term correspondingly. But the inequality here is less than or equal. This implies this is actually equality. Okay, you follow? Just look at this for a moment and see if everything is fine. Okay. In addition, what will this force? This will also force equality on the other things. Is that okay? Now this will contradict F1 greater than F2. Okay, check why. Just look at the definition that this is a contradiction. Okay, that much I need to do. Check that this equality that you see at the bottom, this gives you contradiction to the definition of f of 1 and f of 2 and the inequality f of 1 greater than f of 2. Okay, very easy to check, 2 lines, I leave it to you. Alright, just check that. It will be a contradiction, therefore this is not true, so f of 1 is in fact less than or equal to f of 2, and similarly you can prove for the other pairs also. Okay, that is the end of the proof. Okay. What's the second part of the question? Second part is try to divide and conquer algorithm that computes the leftmost minimum element in each row. And what is the runtime? Okay. So basically you have to compute f of I for every I. Okay. So just give it a thought. Take 2-3 minutes and see what can you do. Okay, so now the divide and conquer algorithm is very simple. Let's have a look at it. So here is the idea. Okay, so what are we trying to find here? Let's give it some name. So it's a function f. So let's just call it f. Okay. Okay, f is the algorithm f of a computes the function is that okay? Let's just call it. So here is the idea. So again, I'll give you outline. First step is calculate. So you're using divide and conquer, right? So you have to go to a smaller algorithm, smaller object. So let a prime be equal to a. It's not n by n anymore, but all the even layers and 1 to n. Okay, what does this mean? You are picking a only over the even rows. 2, 4, 6, 8, 10, only those. And columns, you are picking all of them. Okay, so this is a strictly smaller matrix. It has only half number of rows. Now you recurse, you apply this algorithm, whatever it is, on the smaller thing. Okay, so compute the algorithm f on the array a prime to get the function values, for which values you will get only for the even rows. So you will get f2, f4, and so on. Okay, up to let's say fn. Let us assume n is 0. Okay. Okay. Now what remains? You already have these values. You now only need to compute the odd values, right? F of 1, f of 3, f of 5, f of 7, right? And here is where we are using the previous property. You see this property? This property f of 1, f of 2, f of 3, these are in increasing order, right? So what do you do? For the remaining values, you simply check. Okay, so check values on row 1 up to uh, on row 1 from column 1 to f of 2. Okay, from column 1 to f of 2th column, whichever is the minimum value, that will be f of 1 among these, right? Because f of 1 has to be to the left of f of 2, cannot go beyond f of 2. So just check the values of the array A on row 1 from columns 1 to f of 2th column to find f of 1. Similarly, check values on row 3 from column, which column to which column now? F of 3 is going to be between f of 2 and f of 4. So f of 2 to f of 4. Somewhere in between f of 3 is going to be there. That you'll get by just looking at the minimum, right? So you check across all of these columns to find f of 3. Okay, and so on, right? So this way you will also determine all the odd values. The even values are already determined here. This completes the computation of the function f for all values from 1 to n, right? So that is the outline for the algorithm f of 8. Here, what is a divide and conquer thing? The divide and conquer thing is coming from this. You are applying the same algorithm recursively on a smaller array 8, right? That's the division. You are using a kind of recursion. Okay. So yeah, that is the solution. Now try writing this as an algorithm. Okay, you should go back and try writing this as an algorithm on your own. Okay. So here is another problem. This is just a small variant of the rod cutting problem that we have already seen. Okay, so let's do question number 6. Consider the rod cutting problem. Now, instead of just looking at the length I and the price Pi, we also consider this quantity called the density. Okay, so for a piece of length I, when the price is Pi, we call the density to be the ratio Pi by I. Okay, now let's follow this greedy strategy. What is it? We will cut it into pieces in a greedy fashion. So you first make a piece with the maximum density, then the next with the next maximum density, and so on and so forth, right? So for a rod of length n, cut of a piece of length I such that the density Pi by I is maximum. Okay, that is the first piece you cut. Then repeat the same for the remaining pieces of length n minus I. Okay, for the remaining pieces recurse. Again look at the maximum possible density and cut that much length and repeat. Okay. The idea is that this will not work. This will not give you optimum rod cutting. This will not give you maximum possible price, total price. Okay. What is the purpose of rod cutting problem? What are we trying to do? We are trying to cut it in a way that the total price is maximum. Okay. The question says that this is not possible. There are ways, or there are rods and prices such that if you do this greedily by looking at just maximum density, it will not give you the maximum possible price. Okay, so give a counter example to show that this does not work. Okay, so So try finding out some examples. I'll give you one example that is already in the book. Okay, so I'll write it down. Wait. Okay, so this is a counter example. Right? So take these values I and pi. I'm taking this from book only. Okay, we have seen the. You can check the book. The 120. Okay. What is the ratio pi by I? Is 1, 10, 11, 9. Okay, and n is equal to just 4 because maximum value I is just 4. Okay, so what do we do? Maximum density is 11. So we first cut out length I. So we first cut out length 3. Then only length 1 remains. So now there is no cutting possible, right? Only length 1 remains. So whatever is there, that is there. So total price that we get is for length 3 it is 11 plus for the remaining length 1 it is 1. 12. Oh, sorry. For length 3, it is price is 33. Density is 11. Sorry. Okay. Length 1, price is 1, 34. Okay. However, if you see, maximum possible in this case is actually optimal cutting in this case is 2 plus 2 units. Because for 2, length 2, the price is 20, which gives total price 20 plus 20 equal to 40. Okay. So that's the counter example. The greedy strategy, if you look at densities and pick it greedily, this will not give you the maximum or the optimal possible price. Okay. So that is it about this. Okay. So question number 7 is now really easy. So again about rod cutting problem. So you already know the algorithm for the rod cutting problem, okay, where the length I has price pi, okay. And I want you to do the same thing, write a dynamic programming algorithm for optimal rod cutting, but this time there is a fixed cost C added to it. What does that mean? For every length I, the price is now pi plus C. You understand? Each price pi add a fixed cost C. So for every length I, the price is now pi plus C. So when you have pi plus C, will the algorithm change? How will it change? That is the thing you have to check. Okay. Answer is going to be very much similar to the original algorithm. Okay. So I'm not going to write this down. Very similar. Go back to your lecture slides. I have also given you the code for this. Have a look at it and modify it for prices pi plus C. Is that okay? That is all in question number 7. Nothing more here. Okay. Let's finally do question number 8. Okay, question number 8 is very interesting. Very interesting in the sense, very small modification, but sort of solves the answer very nicely. So question number 8 asks for the following. Write an algorithm to find the length of the longest monotonic increasing subsequence of a sequence of n numbers. You understand? Subsequence which is monotonic increasing and the longest possible length of such a subsequence. Okay? How will you find this? Right? Now, if you look at dynamic programming and divide and conquer algorithms, we have only considered one problem about sequences. It was the longest common subsequence, if you remember, LCS, finding the LCS of two sequences. Is that okay? So you have to use that in some way in order to find the longest monotonic increasing subsequence. Okay. So this is the hint. Take 2 minutes, think about it. You can find the longest monotonic increasing subsequence by using LCS. How will you do it? Think about it. Take 2 minutes. Okay, first thing to realize, in this question you are only given one array, a sequence of n numbers. That's all you are given. But in LCS you have two sequences. So how will you come up with two sequences first of all from one sequence? That is what you have to think about. Okay. Okay, so the answer is very simple. What to do is the following. So question A. Given an array A, let's call it 1 to 1. Use some sorting algorithm. You understand? Use some sorting algorithm. First sort the array. Let okay. Now this is already sorted. So the elements of B are increasing. Okay, in increasing order. Monotonic increasing order. So the longest subsequence of A, which is monotonic increasing, will be a common subsequence of longest possible length between A and B. Okay, so the longest monotonic increasing subsequence of A is simply the LCS of A and B. That's all. So you bring out your usual LCS algorithm. So output is just LCS A, B. That's all. Nothing else. Okay. Elements in B are already arranged in increasing order. Elements in A are as they are. The longest possible monotonic increasing subsequence will also be increasing in B. Right? So it's a common subsequence of both A and B. So you're just looking at the longest length common subsequence of A and B. That's it. That will be the longest monotonic increasing subsequence of A. Alright. So yeah, that is it. That brings us basically to the end of most of the tutorial things. Okay. We have covered almost everything now, even in the tutorials. There were some smaller algorithms on binary search trees that were remaining, which is already there in the book. Okay, so I will maybe run through those once again and put it as a recording at some point later. Alright, so this brings us to the end of the tutorials also. Okay, for our course. Alright, so this is the last meeting that we had. Okay, now there is no more meeting after this. In between, I will post some videos with some, the formal algorithms of what we have already seen, as well as if something extra I think of, I'll post it. Okay, that's it. So if there is anything more that I want to say, I'll post it as a recording. This is the last meeting for this course. Okay, so yeah, so that is the end of this course. We are concluding now. Is there anything that anyone wants to ask or say?
सर वो क्विजेस की पीडीएफ आप कब देंगे?
सॉल्यूशंस ना, हाँ ठीक है, दे देता हूँ. ठीक है, वो कंपाइल करके मैं भेज दूँगा. ओके. आप किसने पूछा था सवाल? प्रिया?
यस सर.
हाँ प्रिया, तुम्ही ने मुझे क्वेश्चन बैंक के बारे में भी पूछा था ना?
किसके बारे में?
पहले कभी तो एक बार क्वेश्चन बैंक के बारे में भी तुमने ही पूछा था ना? क्वेश्चन बैंक.
हाँ हाँ मैंने पूछा था.
हाँ तो प्रिया, तुमको एक मतलब तुम्हारे लिए भी बाकी लोगों के लिए भी एक बार बता देता हूँ कि एग्जाम में, फाइनल एग्जाम में जो क्विज और जो आपका ये लॉन्ग क्विज हुआ है, सिर्फ उसी में से सवाल नहीं आएंगे, और भी अलग सवाल आएंगे, तो पढ़ के ही
ओके.
आना. ऐसा नहीं कि वो सॉल्यूशन देख के रट्टा मार के फाइनल एग्जाम लिखा है. दैट्स नॉट व्हाट इज एक्सपेक्टेड. ओके, पढ़ना पड़ेगा. राइट. फॉर योर इंफॉर्मेशन, नेक्स्ट सेमेस्टर में पाइथन का प्रोग्रामिंग वाला कोर्स आएगा. राइट. पाइथन का प्रोग्रामिंग कोर्स में, ये कोर्स में जो भी सीखा है उसका प्रोग्राम पाइथन में लिखना है बस. वहाँ पे दोबारा नहीं सिखाया जाएगा ये कोई भी एल्गोरिथम. ठीक है. फॉर एग्जाम्पल, आई जस्ट से राइट अ प्रोग्राम टू सॉल्व द मैक्सिमम सब एरे प्रॉब्लम, फुल स्टॉप. फिर प्रोग्राम लिखना होगा वहाँ पे पाइथन में. प्रोग्राम को रन करना होगा, आउटपुट आना चाहिए ठीक से. उसमें एरर आएगा तो एरर को ठीक करना. वहाँ पर जाके मैक्सिमम सब एरे प्रॉब्लम नहीं सीखना है, वो यहाँ पे ही सीखना है. Okay, so take this very seriously. You still have time. Take this seriously. Don't rely on just question bank and these kind of ideas. This is not how you learn something. Okay, so yeah. Anything else? Okay then. So thank you and good luck. Chalo, bye bye.
थैंक यू.